so mad. All right, so, all right. First thing, in order to do the new stuff, okay, in order to do the new stuff, I don't like that there. You have to know what a strong acid is. So I want to tell you what a strong acid is. Okay, there are multiple, I want to say 2, there might be 3 questions on which of the following is a strong acid and a strong base. So make sure that you get this. We're going to practice. Now, there's 2 kinds of acids. This is from last Monday. There's binary acids. And you guys remember what the other one is? Oxyacids. And oxyacids contain hydrogen. Or, sorry, all acids contain hydrogen. What do oxyacids contain? Oxyacids. All right, now, there are different rules for both. So, and this one is the one that you have, there's the strong acid and the strong base rule you have to memorize. Of the binary acids, there are 3, HI, HBr, and HCl. Every other binary acid is weak. These are the only strong. Now, you are going to have to memorize this. How I help my students memorize this every year, I go HI, it's high. It's your teacher's name. So, HI is strong. Look at the periodic table. HBr rate above it is strong, and HCl is strong, but every other binary acid is weak. So H2S is binary, it's weak. HF is binary, it's weak. So HI, think of my name, and then the 2, and then fine iodine, and then the 2 things stacked on top of it are also strong. So HI, or hydroiodic acid, hydrobromic acid, and hydrochloric acid are strong. Now, the oxyacid rule is weird, so I'm going to put it in words, but then we're going to practice. So if the oxyacid rule is if the number of oxygen atoms exceeds the number of hydrogen atoms by 2 or more, the acid is strong. Now I'm going to back away from the whiteboard so you guys can have this. Now, so this rule is if the number of oxygen atoms exceeds the number of hydrogen atoms by 2 or more, the acid is strong. It's been my experience that it's good if I pause for a minute and practice this. Are you ready? All right, so let's practice. Okay, tell me, and I'll go back if you want. HNO3, is this a strong oxyacid or a weak oxyacid? Strong or weak? Strong, because there's 3 oxygen and there's 1 hydrogen, and 3 minus 1 is 2. What's the rule? 2 or more. This is strong. Okay, let's do HClO4. By the way, this is the strongest acid I know of. Strong or weak? Strong. 4 oxygen, 1 hydrogen. 4 minus 1 is 3. The rule for a strong oxyacid is that the oxygen exceeds the hydrogen by 2 or more. Nitrous acid, NO2, is not strong. It's what? Weak. Why is it weak? Yeah, because the difference between the hydrogen and the oxygen atoms is 1, not 2 or more, correct? Now, sometimes you get weird things like this that confuse kids. I'm not sure why, but I just want to do this. This is vinegar. This is acetic acid. And if you look at this, does everyone see that there's 4 hydrogen and 2 oxygen? And so does everyone see that? And sometimes people will say, oh, okay, well, then it's strong. No. It's weak. Why? Because the oxygen needs to exceed the hydrogen, not the hydrogen exceed the what? Oxygen. So if you go back, I'm going to go back a slide, but the rule for strong oxyacids is if the number of oxygen atom exceeds, that means it has to be bigger than the number of hydrogen atoms by 2 or more. The reason why I'm hammering on this, although it ends up not really mattering, is because the technique I'm going to teach you today only applies to strong acids and strong bases. There's something totally different you have to do for weak acids and weak bases, and that's considered a college level concept, not a high school level concept. The AP kids got to do it because they get credit for college chemistry, but you guys don't. And so just know, don't go to college in 2 years and say, oh, it's not how Mrs. High told us to do it. This only works for strong acids and strong bases. It doesn't work for weak acids or weak bases. And that's beyond the high school curriculum. You guys okay? Now, here is the rule for strong bases. Oops, Mrs. High went the wrong way. All right, new slide. Okay, here's the word, strong bases. This is pretty easy. It's group 1. Oops, since I'm taping this, I should probably write a little nicer. Group 1 or group 2 hydroxides. All right, now let's practice this for a while. What does a base have in it? What does a base have? Acids start with hydrogen. What do bases end with? Hydroxide, right? Actually, some of them, but for the case of us, because we're just doing strongs. All right, so for instance, here is why pOH is a strong base. Everyone find K. Is K in group 1 or 2? 1, it's strong. How about sodium hydroxide, which is Drano? Is that a strong base? Yep. Why? Because it's in group 1. And then barium hydroxide is also a strong base because barium is in group what? What group? 2. Now, interesting, aluminum hydroxide, this is one of the ingredients, the active ingredient in Tums. Aluminum hydroxide is in Tums. It's a weak base. That's why you chew it up and swallow it and you don't get a bunch of chemical burns. But if you find aluminum, aluminum's not in group 1A or 2A. It's in group 3A, and that means it's what? Weak. So the rule for bases is if you have group 1A or 2A paired with a hydroxide, it's strong. And if you have any of the other atoms paired with hydroxide, it's what? Weak. All right, so far so good? Because the technique I'm going to teach you today is, and I'm going to write it down because I want this to be good. The technique for the problems, this is pOH day 2. The very first thing you need to do is verify, and there's nothing you have to write down. Verify that the acid or base, depending on what the problem is strong. Now, let me say this one more time. It ends up not mattering because I'm not going to give you a problem you can't do, but I want you to take this to college with you. This process that you're learning today does not apply to weak acids and weak bases. It only applies to what? Strong acids and strong bases. And here's the difference. Strong acids and strong bases ionize completely. They will ionize until it's all ions and no molecules, and I'll talk about what that means. So, write the dissociation equation. And if you don't know what this is, this was the Arrhenius worksheet, and we're going to review that. Write the dissociation equation. 3 underneath the equation. This is the new part. Underneath the equation, set up an ICF chart. And then 4, answer the question. By the way, guys, when you get your assignment today, I'm gonna wait for you to catch up. When you get your assignment today, I did this on purpose. The absolute worst 2 problems on the whole assignment are the first 2. They're the most difficult ones. Why would I put that 1 and 2 instead of, yeah, because hopefully I'll be done by noon and you'll have 15 minutes. And so I wanted to be here if you got stuck. The last 2 are bad also, but don't worry so much about that. Okay, so, because they're bad because they're review. Yes. Chart. ICF chart. Now I'm going to tell you, that's the new part. Have you ever heard of an ICF chart before? I stands for initial, C stands for change, and F stands for final. So initial, final, does that make sense? And then the middle is change. All right, so here is your first problem. I'm going to be doing 4. 1, calculate the hydrogen ion concentration in a 0.050 molar no, that's not what I want to do first, HNO3 solution. Okay, so just stay with me. All right, step 1. It's back a slide, but I need to verify that this is either a strong acid or a strong base, because what I'm teaching you only applies. What is HNO3? Strong acid. Why is it strong? Because there's multiple choice questions like, which of the acids below is strong? And 3 of them are weak, and 1 of them is strong. You with me? And then you pick the strong. Or which of the following of the 3 acids is weak? And then 3 of them will be strong, and 1 of them will be weak. All right, now, step 1, verify that it's a strong acid. It is a strong acid because you have 2 or more. 2, write the dissociation equation. So what happens, people, when you throw HNO3 into water? It dissociates into, and remember now, here's why it only applies to strong acids. Strong acids and strong bases dissociate completely. Okay, and so what does it dissociate into? It dissociates into H plus, right? And NO3 what? Minus. And if you want to put 1s here, you can, but we get lazy in this chapter. Again, I'm going to say this, but what do ions have? What do ions have? Charges. What do strong acids and strong bases do? They ionize completely, meaning they go from, this is called this side is a molecule, right? This side is what? Ions. One side is molecule, one side is ions. Strong acids and strong bases ionize completely. Now, do you guys get that this is the dissociation equation and it's Arrhenius acid-base theory? Okay, underneath this, we're going to put ICF. It's the first time you've ever done this. I stands for initial. C stands for change. F stands for final. Okay, and by the way, this one is so easy that kids think that this process is stupid. Like, if you get the same answer, why do you bother? But wait till the next problem. I'll show you when you don't. All right, so you look up at the problem. The problem tells you that initially the concentration of NO3 is 0.050. And we don't have to have an M, because if you set up your ICF chart and then in parentheses you put the unit, then you don't have to write it down every single time you have a number. Okay, so initially, we think of this before you mix the 2. So so I have this HNO3 powder, let's say, and I have some water, and before I put them together, in theory, it should be 0.050 molar. Initially, you have none of this and none of this, okay? Now, what makes something a strong acid or a strong base is all of this go away. All of this leaves. All of this leaves, leaving you a final concentration of the molecule of what? 0. Now, this seems like it's redundant, but trust me, when I do the next problem, it's not. I'm going to switch colors. Does everyone see that we have a 1:1 mole ratio? So what happens is when you have a 1:1 mole ratio, it also works for molarity, because we just ignore the liter. If this went down 0.05, these have to go up 0.050. Okay, now why is one side negative and one side positive? Because as the reaction proceeds, this molecule goes away. Is this the sign for going away? And this comes, and again, I need you to understand this is negative because it's going away. This is positive because as it hits the water, the products are produced, their concentrations go up, the reactant breaks apart, its concentration goes down. And the way that you get the final is that you add these. So 0 plus 0.5 is 0.0.5, 0.0.5, and we have almost all of the work done for this problem. Now, guys, I'm going to do 4 of these, but answer the question. What did the question ask you? Read the question. What was the hydrogen ion concentration? Guess what? Go to the final row, because that means at the end of the lab. Go to the H plus column. The answer to this question is, let me extend this. What is the hydrogen ion concentration? 0.050 molar. Comes right off the table. Now, that's not always true, as you'll see in my next example. Are you ready? All right. This is, I had Micah grade this one on your Arrhenius worksheet, but I'm still hanging on to them because with AP testing, once I put it back, people have to do it in front of me. But here is my second one. I'm going to do calculate. Sorry. Let's go again so people are here. So calculate the pH of a 0.050 molar barium hydroxide solution. That's the abbreviation for solution. This one already is quite a bit more complicated. Correct? All right, no, you're not going to multitask. This is the hardest stuff in the entire chapter. All right, so, all right, step 1, verify, is barium hydroxide an acid or a base? Base. Why? Because acids start with hydrogen, bases end with hydroxide. Is barium a group 1 or group 2 ion? Now, I had Micah grade these in all 3 sections, and very few people got this right, so pay attention. And first time Duffy taught this course with me, I told her, I said, you are going to be shocked at how difficult the kids find this. So here's the deal. Step 1, verify that you have a strong acid or strong base. It ends up not mattering in here, but why am I telling you this? Because this ICF chart only applies if it's strong. If it's weak, it's called an ICE chart, where E stands for equilibrium, and there's a totally different process you have to do. Okay, now, let me do this. This is what I told Duffy. Let's do the words. What does barium hydroxide dissociate into? Use the words. Barium hydroxide is going to break up into barium and hydroxide. It's not going to break up into barium and oxygen and hydrogen because the polyatomic ions stay together. That's why you had to memorize their names. So barium hydroxide is going to dissociate into barium ions and hydroxide ions. Now, barium ions, why do I put a +2 charge there? I don't know. Look on your ion sheet. What's the charge of barium? +2. Why is it +2? Because we talked about if it's in group 2, it wants to give away 2 electrons to turn into a noble gas. Now, hydroxide is OH minus, correct? Right? Is that what hydroxide is? You can't change the charge on hydroxide. But because of this here, how many hydroxides? 2. And we put it up here, and here's why that's important. Unlike the last problem, this is not a 1 to 1 to 1 mole ratio. It's a what? 1 to 1 to 2. And so kids will say to me all the time, like 90% of the time, Mrs. Hyde, the number in the problem is the same as the H plus or the OH minus, but not always, as you'll see in this problem. Now, I stands for initial, C stands for change, F stands for final. Initial comes out of the problem. What does the problem tell you? The initial concentration of this is 0.050 molar, just like the last one, correct? Although the last one was an acid. This is 0 and this is 0, and here's where life gets interesting. By the way, I would go so far as to say this. The initial concentration of the base is in the problem, and the ions are considered 0. And then when they come together, what makes something a strong acid or strong base is all of it goes away. Correct? All of it goes away. 100% ionization means 100% of this turns over to ions. Now, here's where life gets crazy. This is positive 0.050. Now, here's where I can't lose you. Zach, this is why I took this away. This is the hardest problem. Okay? Do you guys see that this is 1 to 1? Correct? But this is 1 to what? This is not 0.050. It's 0.050 times 2. So, and I picked 0.05 because think money. Is that a nickel? So what is 0.05 times 2? Does everyone get that this is going to be 2 times 0.05, which is 0.1? Correct? All right, now what's the end column? The concentration at the end of this process of barium is 0.05. We don't care. The concentration of the hydroxide at the end of this process is 0.1 molar. Now, step 1, verify that you have a strong acid or a strong base. Step 2, write the dissociation equation. Step 3, underneath the dissociation equation, set up an ICE chart or an ICF chart. Initial, change, final. Now, then 4 is answer the question. Here is the crazy part. This one actually, step 4. Okay, what is acid-base chemistry all about? It's about H plus for acid and what? OH minus for base. Now here's what I know after my ICF chart. I know that the concentration of hydroxide is 0.1 molar. That's not what they asked for. They asked for the pH. Okay, so this is yesterday's worksheet. Now, is everyone okay with the 0.1? Now, the first thing I need to do is to get the pH, first I have to get the pOH because our pH and pOH connected. And so the pH is the negative log of 0.1. Pick this on purpose because it's 0.1 the same thing as 1/10 or 10 to the negative 1. So log base 10 of 10 to the negative 1 is negative 1, but then when I take the opposite, so here's what I know. The pOH is 1.00. But I didn't ask for the pOH. What did I ask for? pH. What's the pH? 13, because what do the pH and pOH have to add up to? 14. And so now, is a pH of 13 very, very basic? And is BaOH2 a strong base? So it doesn't. All right, so do you guys get what I mean when I say answer the question? The chart tells you, because acid-base chemistry is all about H plus for acids. And so once you get here, this crashes to yesterday's worksheet that a lot of you are not having problems with. All right, now here is my second to the last problem. What do I want to do now? Let's do it. Nah, maybe this will be my last problem. 3. I did this on purpose because you guys did so horrible, and it's true every year because this is last year's lecture notes. A solution is made by dissolving 1.50 grams of HI in 500 milliliters of solution. What is the pH? By the way, this is like the last 2 problems. This is like the last one. Okay, so the first two are tough because one is an acid, and I give you H plus, but I ask for OH minus, so you got to go from H plus to pH to pOH back to OH minus. This one's tough because look at the circle on the board. What were you guys really bad at the last test? Molarity. Do you notice that I didn't give you the concentration? So on this, this is molarity. So let me do this. Before I can do anything, I got to figure out what is the molarity or the concentration of the HI. Now that was a three-step process. Step one, make sure the volume is in liters. Is the volume in liters? No. How many times do you move it to get it into liters? 3. 1, 2, 3. So the first thing, step one, the volume is 0.500 liters. There's only 3 steps. Step one, make sure the volume is in liters. Step two, do what the circle tells you. Now they can't see the circle on the board, so here's the goal. If you want molarity, it's moles or mass over, this means over, the volume in liters. We want molarity, so the molarity is going to be 1.50 grams on top of 0.500 liters, because that's what the circle tells you to do. Now, let me draw my hand. The circle tells you if you're solving for molarity, in the problem, they have to give you moles or mass, and that goes in the numerator. And then step 3 is use molar mass as needed, and we need it. Why? Because molarity units are moles per liter, and we have grams per liter. So then I go to my periodic table to get HI. H is 1.008. And I is 126.91, and I add this together and I get 819. 127, the rule in chemistry is you keep 2 decimal places. Molar mass of HI is 127.92 grams per mole. I'm going to erase this. This is just total. This first part was just me being evil because you are bad at molarity. Where does the 127.92 grams go if it needs to cancel? So 127.92 grams in 1 mole. Grams cancels with grams. Put this on a calculator. This has 3 sig figs. This has 3 sig figs. This has 5 sig figs. How many sig figs do you think you want? 335. What do we get? 1.50 divided by 0.5 divided by 127.92, rounded to 3 sig figs, 0.0235 molar. You guys okay? Everyone know this is review. Now I'm ready to do the new stuff. Oh, I lost it, but I can scroll up there. All right, HI, step 1 on the new stuff. Is HI a strong acid or a strong base? It's binary. What's the rule for binary? High, my name, HI is strong. 1 above it, HBr is strong. 1 above it is HCl is strong. All other acids are weak, so we can do this. So go H plus and I minus, because acid-base chemistry is all about H plus and I minus. Okay, now step 3, set up an ICF chart. I stands for initial, C stands for change, F stands for at the end, final. Now, this is point, I just did this. Let me toggle up here. Initial is 0.02, was there a 0 in front? Yes. 0.0235. This is 0 and this is 0. Guys, you can't do this process for weak acids because they don't ionize completely. It's going to be something less than this, but this is strong, so it all goes away. This one's easy again. Does everyone see that it's a 1 to 1 to 1 mole ratio? So all of the numbers are the same. When is the only time they're not going to be the same? If you don't have a 1 to 1 to 1 mole ratio. Right, multiplying by 1, dividing by 1, not going to change numbers, but the previous problem where it was 1 to 1 to 2, that last number changed. So this goes to 0, and this goes up 0.235, and this goes up 0.0235, and you get this by adding. Okay, now, stopping for a minute. How am I doing? We're almost done. What is acid-base chemistry all about? It's about H plus for acids and about OH minus for bases. All right, now this is what I know after my HF chart. Here we go. Whoops, put the pen down. This is what my HF chart tells me. The hydrogen ion concentration is 0.0235 molar. Too bad that's not what I asked. What did they ask for? pH. But can you get the pH from the hydrogen ion concentration? Yeah, you have this equation, which is the pH is the negative log of the hydrogen ion concentration. So the pH is the negative log of 0.0235. I pop that into my calculator, negative log 0.0235, and my calculator says 1.63. Fabulous. All right, guys, I am going to give you the worksheet on this, and know that the answers are off slightly because I'm not teaching you the real sig fig rules. The real sig fig rules are very confusing. So when you look at the answers, just get close to the answers. Do you want me to tell you what the real sig fig rules are? All right. Now, because it's prom weekend, this assignment is not due till Tuesday. However, you are also getting a big assignment on Monday. So you might be really in trouble if you don't even do this. Now, I would like you to try 1 and 2, because where did I put the 2 worst problems?
1 and 2.
At 1 and 2, please say this is going. 31-minute lecture.